Hello and welcome to the Abingdon Physics YouTube channel. Today we're going to be looking at Edexcel IGCSE Physics, Topic 6, Magnetism and Electromagnetism, in particular the Magnetism section of that. So this video will be useful for both double award and triple award, and we'll be covering spec points 6.2 to 6.7, which are on screen now. So our first spec point is spec point 6.2, to know that magnets repel and attract other magnets and attract magnetic substances. Well, we know there are three magnetic elements: iron, cobalt and nickel. Now, there are other magnetic materials as well, such as steel, and these are magnetic because they contain iron within them. Magnets can have either a north or a south pole. North and south poles will attract to each other, whereas north and north poles will repel and south poles will repel. And we can see these in this diagram here. So our next spec point is 6.3 to describe the properties of magnetically hard and soft materials. Well, magnetically hard materials are difficult to magnetize and difficult to demagnetize. And these can include materials such as steel, and these are useful to make permanent magnets out of, such as bar magnets. Whereas soft magnetic materials, they are easily magnetized and easily demagnetized. Now this is a material such as iron per se, and this is really useful to make electromagnets out of, because of that ability to magnetize and demagnetize easily. But we'll talk about electromagnets a bit more in a later lesson. So spec point 6.4 is to understand the term a magnetic field line. And a magnetic field line can be really simply defined as a visual tool to help us represent magnetic fields. And as I go into the next few spec points, I'm going to show more and more what that means and how that helps us. But all we need to think about it as now is it is a visual tool to help us show magnetic fields. So spec point 6.6 is a practical to investigate the magnetic field pattern for a permanent bar magnet and between two bar magnets. Well, the permanent bar magnet question is one of the most common GCSE questions going, and it comes up almost every other year. So this is really important that we get down. So I have now added a permanent bar magnet to my drawing here. The way to find the magnetic field pattern would be to first place a compass next to the permanent bar magnet like so. Now that we have the compass in place, we can add more compasses so that the pointers all line up and eventually it will look like so. If we were to draw over where the compass pointers line up, that would give us a magnetic field line. And we would repeat this process multiple times, eventually getting the magnetic field pattern for the bar magnet, which looks like so. It's really important when we answer this question, we talk about using a compass rather than iron filings. And we use a compass because we can get the direction of the magnetic field with a compass. And the direction of the magnetic field is always pointing towards the south. So we can do the same process to find the magnetic field between two like poles and two different poles. So first off, looking at two different poles, the magnetic field would look like so. And now looking at two like poles, the magnetic field would look like so. And we notice for both drawings, the arrows are always going away from the north towards the south. So spec point 6.7 is talking about how to use two permanent magnets to produce a uniform magnetic field. So if I set up my two permanent magnets with different poles like so, we end up with a magnetic field like we just saw in the previous question and we can see here. So this is a uniform magnetic field because it is the same strength everywhere. And we can tell that because the strength of a magnetic field is given by the distance between its field lines. So no matter where I look now in this dotted region, the field lines are always the same space apart. Whether it's here, whether it's here, or whether it's here, the distance between the two field lines is always the same. So we could also make our magnetic field stronger by bringing our north and south pole closer together, and that would make our field lines closer together, and we remember they'd be closer together because the closer together the field lines are, the stronger the magnetic field. And our last spec point today is to know that magnetism is induced in some materials when they are placed in a magnetic field, and that is simply stating that materials made of iron, nickel, cobalt, steel will become magnetic and will attract to magnets if placed in a magnetic field. So let's look at some questions to do with this topic. So we have, which of these diagrams correctly represents the magnetic field around a bar magnet? Well, it's not A, because these arrows up here are going from south to north. It is not C, because all of the arrows are going from south to north. And it is not D, because this arrow here is going south to north. So it must therefore be B as the correct answer. An important note about field lines, which I haven't mentioned yet, is that they should also never cross. We should never have field lines that cross, as that would indicate an incorrect diagram. So now let's move on to part II, and which one of these arrangements indicates a uniform field between the poles. So if I was to draw my field lines for A, they would look something like so, with our arrows going from north to south. If I was to draw our field for B, well, this is two north magnets, so these are going to repel and look something like so, away from each other. So that is clearly not a uniform field, as there is different spacing everywhere. Now, C and D look at first glance that they would both be possible. But if I draw the field lines on for C and D, C's will look like so. We notice that there is constant spacing between the field lines for C, therefore showing this is a uniform field. Whereas for D, with the field lines now drawn on, we can see they are further spaced out near the South Pole than they are near the North, therefore meaning that is not a uniform field and that our answer should be C. So on to our next question, where we have two bar magnets placed close together. There is a south and a north next to each other, and these are opposite poles, so therefore they will attract. And state the name of a material that would be suitable for use as a permanent magnet. The answer that is best there is steel. So on to our really common question with this topic, and this has come up almost every other year for the past 10 years. So describe an experiment to investigate the magnetic field pattern around a permanent bar magnet. You may draw a diagram to help your answer. So your diagram should look roughly like so. And with a diagram like so, we will state that we will use a compass to find the direction of the field. That's really important that we're saying a compass, because iron filings or another method will not give us the direction. So we'll use a compass to find the direction of the field, and we will line up multiple compasses to find the whole field pattern. And if we check our mark scheme, we see that the 3 marks are actually incredibly easy to get, because we can get 2 marks for saying use a compass to show direction, and then a 3rd mark for saying use multiple compasses. Thank you for watching this video. This has been the Abingdon Physics YouTube channel. Please like and subscribe the video, and I will be in the comments ready to answer any of your questions that you may have. Thank you for watching.